Welcome to the Unit 5, Section 4 video on solving by substitution. Sometimes it is difficult to identify the exact solution to a system by graphing. In this case, you can use a method called substitution. The goal when using substitution is to reduce the system to one equation that has only one variable. Then you can solve this equation and substitute into an original equation to find the value of the other variable. So in order to do this, you're going to solve for one variable in at least one equation. Substitute the resulting expression into the other equation. Solve that equation to get the value of the first variable, and then substitute that value into one of the original equations and solve. Now I know that this sounds like a bunch of word soup, but I think it's more straightforward when you see it done in examples. And of course, you're going to take the values that you get and write them as an ordered pair, and do a check to make sure your answer is correct. So let's use substitution to solve the system of equations listed here. Now we don't have to solve for a variable because both are already solved for y. So since both equations are already solved for y, we have y equals 2x as one of them, and y equals x plus 5 as the other. So let's substitute 2x in for y in the second equation. So since y equals 2x, I can put 2x in place of y. Now I'm going to solve this for x by subtracting x from each side. So when I subtract x from each side, I get x equals 5. Now that I have x equals 5, I'm going to go back and substitute into one of the two equations my value for x. So I'm going to do it in the first one. Put 5 in place of x, and then solve. 2 times 5 gives us 10. So our x value is 5, our y value is 10, so our solution is the ordered pair 5, 10. Now let's look at this system. The second equation is already solved for y, so we've already got that first step under control. Our second step is to take our value for y, or our expression for y, which is x minus 4, and we're going to plug it into the other equation. So in this case, we are going to take y and in place of it put x minus 4. We're going to substitute that. Then we are going to simplify by combining like terms. 2x plus x gives us 3x. Add 4 to each side, which gives us 5 plus 4 equals 9 on the right. And then divide by 3, which gives us x equals 3. Now that we have a value for x, we're going to substitute 3 in for x in the second equation. I always like to work with the equation that's going to be easier to work with. So we put 3 in for x. 3 minus 4 gives us negative 1. So our solution is the point 3, negative 1, our x value and our y value. For this example, we have neither equation solved for a variable. So I'm going to solve the first equation for x. It doesn't have to be solved for y. You can solve it for x if you want to. And the reason I'm doing that is because x is already by itself. It doesn't have a coefficient. So I'm going to subtract 4y from each side and get that x is equal to 6 minus 4y. Now I'm going to substitute 6 minus 4y in for x in the second equation. So here's my second equation. In place of x, I'm going to put 6 minus 4y, and then I'm going to simplify. So we're going to combine like terms first. Negative 4y plus y gives us minus 3y. Subtract 6 from each side, and then divide each side by negative 3, and we get y equals 1. Now we're going to write one of the original equations. We'll do x plus y equals 3, substitute 1 in for y, and then we'll subtract 1 from each side, so we get x equals 2. So our solution to this one is the ordered pair 2, 1. Sometimes you substitute an expression for a variable that has a coefficient. When solving for the second variable in this situation, you can use the distributive property. So let's use substitution to solve this system. Again, we are going to solve the second equation for x because it's really the only thing that doesn't have a coefficient attached to it. So we take the second equation, solve it for x by adding 4y to each side. Now when we plug this expression for x into the first equation, you notice that when we put it in for x, we're going to have to distribute the -5. So we'll distribute the -5 to the expression into parentheses. So -5 times 4y gives us -20y. -5 times 11 gives us -55. Combine like terms. So 4y minus 20y gives us -16y. Add 55 to each side, which gives us 64 on the right, and then divide each side by -16, which gives us y equals -4. Now we're going to plug that value for y into one of the two equations. And let's substitute it into the second one because it looks easier to work with. So we substitute -4 in. -4 times -4 gives us positive 16. Subtract 16 from each side, and you get x equals -5. So our solution is the ordered pair -5, -4. A special solution occurs when the variables cancel while solving a system of linear equations, very much like they did when we solved an equation itself. The system has infinite solutions if the result is a true statement, such as 4 equals 4, and the system has no solution if the result is a false statement, such as 6 is equal to 12. They are not equal to each other, so it's a false statement. So this is very similar to what you've already dealt with when you had special solutions for when you just were solving for one variable. The rules are the same. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you. And if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.